Hello, this financial markets lecture presentation is on interest rate swaps. I'm Pat Obi, Professor of Finance at Purdue University Northwest. And I begin here with a definition of an interest rate swap, which is an agreement between two parties where a set of interest payments is exchanged for another set of interest payments. Now, like all derivatives, a swap begins with a definition in the manner that I have shown it. It's always going to be an agreement between two parties. And then beyond that point, you can delve into the specific aspects of that particular derivative. Anyhow, in interest rate swaps, as I note here, typically exchange a fixed interest rate payment for a floating interest rate payment. And in such swaps where one party agrees to pay fixed while receiving floating, we call that a plain vanilla interest rate swap. And here's a quick example. Suppose firm A enters into a swap with a counterparty. In the swap, firm A pays fixed at the interest rate of 7.5% and receives floating. The floating interest rate is going to be based on LIBOR. LIBOR is London Interbank Offered Rates, which is a key short-term interest rate set by the British Bankers Association. And this particular swap is going to be initiated on December 15, 2016, and it's going to last for a year, ending December 15, 2017. Now, as I note further, the payments are going to be made quarterly. And so with the swap beginning, with the initiation of the swap being on December of 2016, the first swap payment will take place 3 months later on March 2017. The second one, June 2017, and so on and so forth until the final payment on in December 2017. So now I summarize. Swap initiation, December 2016. The notional amount of the swap is $50 million. Now that means that the interest payments that are going to be made will be a percentage of $50 million. Now this $50 million itself is not going to be swapped. It's the principal value, and since the principal value is the same for both the fixed and floating interest rate, it will not be exchanged. It's not going to be swapped, and so it simply is a notional amount. What's going to be exchanged, so to speak, would be the interest payments based on the rate of based on the fixed interest rate and the floating interest rate, whatever it turns out to be. Now we're going to be evaluating this swap from the viewpoint of firm A, which is the firm paying fixed interest rate. And analyzing a swap, it's not necessary to be looking at the transaction from the viewpoint of both parties. That could additionally be confusing. So just choose a party, and you know that whatever that party does, the flip side of it is going to be what the counterparty will do. Now these two parties have agreed that the days and year to be used is going to be 360, and that's basically to facilitate the interest rates that would be applied. Now the floating rate that's going to be used here is a 90-day LIBOR. 90-day LIBOR is basically the quarterly LIBOR rate. So the settlement type here is going to be as follows. I'm going to go back to this illustration here. Now we know that each of these periods, fixed interest rate is going to be 7.5%, which is going to be made by firm A. However, the floating rate really should be the LIBOR that occurs in March for the first payment, the LIBOR that occurs in June for the second payment, the LIBOR occurring in September for the third payment, and finally LIBOR for December to determine the floating interest rate for that particular payment period. However, these two parties have agreed that rather than wait until March to wait and see what LIBOR would be, which of course is going to cause quite a great deal of uncertainty and anxiety, they have decided that the floating interest rate payment that will be used to determine the March payment would be the LIBOR established back here in December. Likewise, the floating rate that would apply for the June payment would be one that was determined already back here in March. And the floating rate payment here is one was determined right here in June. And finally, the floating rate payment here would be based on LIBOR in September. So in essence, 1 quarter ahead, the parties know what the cash flows are going to be. Of course, the fixed is known beforehand, and in this manner, the floating would also be known beforehand, but a quarter in advance, 3 months in advance. Beyond that point, though, they will not know, of course, what floating rates would apply for June, September, and December until you get to those periods. This type of arrangement where the floating interest rate is based on the previous period's floating interest rate is called advanced sets, settled in arrears. And so in this first payment, in the first swap that's going to take place March 2017, the LIBOR that's going to be applied here would be the LIBOR determined back in December of 2016, and that rate was 7.68%. This is just an example. So what this means is firm A pays the fixed payment, which of course is going to be 7.5% adjusted for 3 months for a quarter, which is what you see here, because 7.5% is an annual rate. So you take the quarterly rate, 7.5% adjusted for the quarter would give you 1.875. That's what this says. So 1.875% of 50 million will give you 937,500. So this essentially is what firm A would be paying, and then firm A would be receiving from the counterparty $960,000, which is 7.68% adjusted for the quarter multiplied by 50. So now, this is basically the way that the swap takes place. A pays this and receives this. But think about this. We can see that A wins in this first salvo, in this first round, because it pays an amount less than what it receives to the tune of $22,500. So actually, the way that this happens, rather than firm A sign a check for $937,500 over to the counterparty and then receive a check for $960,000, which of course we know that firm A wins by this amount, what the parties are actually going to do is to simply determine this net amount, and then whoever the game is against, so to speak, is the party that simply would sign this check. So the counterparty would simply sign a check for $22,500 and give it over to firm A, and that's it for this first payment period. So in actuality, you don't really exchange these amounts. You simply give the net amount to the party who wins in that particular period. Second payment, let's see what happens. Here, LIBOR, which was determined back in March, was 7.5%, which, as it turns out, is exactly the same interest rate as the fixed interest rate right here. So as you can see, the payments are identical. It's a wash. So net payment is 0, and so no payments exchange hands. Third payment, let's see what happens here. LIBOR that was established back in June was 7.06%, and that's what's going to apply right here. And as you can see, firm A is going to be paying more than what it receives from the counterparty, to the tune of $54,500. So essentially what happens is firm A is going to have to sign a check for $54,500 and give it over to the counterparty. Sorry, firm A loses right here. Fourth and final payment. Let's see. Back in September, LIBOR was 6.5%. And so here in the final payment in December, we can see again that firm A is going to be paying an amount larger than what it gets from the counterparty, to the tune of $124,500. So once again, and for the final time, firm A is going to have to sign a check for this amount and then pay it over to the counterparty. And that really concludes this swap example. Now in example number 2, we have firm X, who's going to be paying fixed at the rate of 5% and receive floating. However, this particular swap takes place every 6 months. It's going to go on for 3 years. and the notional principal here is $100 million. And so here's a summary of it. All right, the swap is going to be entered into in March 2017, and payments will take place 6 months. Floating rates would be based again on LIBOR, and they're going to do advanced sets settled in arrears again. And so what happens is the first LIBOR is 4.2%, and since payments are going to be made semi-annually, that's going to be 2.1% every 6 months. So here's a summary of it all. March 2017, they signed the agreement. First payment will take place September 2017. Now, as it turns out, for this first set of payment here, LIBOR back in March was 4.2%. So semi-annually, it's 2.1%. 2.1% of $100 million is $2.10 million. This is the floating cash that firm X here would receive. And again, we're looking at this from the viewpoint of firm X. So firm X receives 2.10. I use the pluses here to denote that these are going to be the cash inflows, the money that firm X receives, and the negatives here would be the cash outflows, the fixed cash payments that firm X is going to be making. So the question here is X is on top, or is it at the short end for each of these periods? As you can see here, for this first payment period in September, firm X receives 2.10 and pays 2.5. But essentially, as you can see, the net payment to firm X is 0.4 million. So essentially, really, the swap requires firm X to simply sign a check for $400,000, sign it over to the counterparty. In the same vein, the next payment period in March, firm X is going to sign a check for 0.10 million over to the counterparty. The third one, though, firm X smiles, it's on top to the tune of 0.15 million. So it's going to receive a check of 0.15 million from the counterparty, and so on and so forth. And that's how this swap is going to take place for the next 3 years. Finally, I show an example here of how we can hedge income gap with a swap, with an interest rate swap. Now, recall that gap refers to the difference between rate sensitive assets and rate sensitive liabilities. As a reminder, here's a quick example. Let's say that a bank's rate sensitive assets is 17 million. Its rate sensitive liabilities is 10 million. Now, rate sensitive assets and rate sensitive liabilities are those assets and liabilities that would have to be repriced or which mature within the same period of time. So here we find that the amount of assets that would be repriced in the same period of time as the corresponding liabilities is 17 million, which is $7 million more than the rate sensitive liabilities. So gap is simply RSA minus RSL. In this case, $7 million. So what's the deal here about gap? Well, as you can see, if interest rates were to go down, for example, by 1% right here, this means that the bank's interest income would fall by $170,000. He's going to be getting $170,000 less on account of this reduction in interest rates. Similarly, the bank is going to be paying less in liabilities. Its interest expenses will drop, but only by $100,000 because it has only $10 million of rate sensitive liabilities. So as you can see, its interest income would drop by a whole lot more than its interest expenses. In fact, by $70,000. So what this is telling us is that the bank's net interest income, which is the difference between its interest income and its interest expenses, would go down by this amount, $70,000. Now, you can also find this $70,000 directly by simply multiplying the gap of 7 million by the change in interest rates, in this example 1%. So either you do it the old school method by looking at the difference between these two amounts, or you simply multiply this by the change in interest rates to find by how much the bank's net interest income will go down. Now, this is interesting because you probably watch television, listen to the news, and hear about how it is that falling interest rates are often not good for banks. But that's because banks typically have asset sensitive gaps, meaning that their rate sensitive assets are often larger than their rate sensitive liabilities. And so whenever interest rates go down, the 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 outcome that often results is that the bank's net interest income goes down. So now the question is, can the bank do something about this? Well, yes. To reduce this interest rate risk exposure, the bank may choose to use interest rate swap by, in this example, paying floating on the $7 million of gap while receiving fixed interest rates on the same $7 million of gap. So what this does is you sign a swap agreement, and in the swap, the bank pays floating while receiving fixed on the notional amount of 7 million bucks, so that, say, interest rates go down by 1%. What happens is the bank will pay 1% of 7 million. What is it? 70,000 bucks less. So the savings on this swap would perfectly offset the loss in the bank's net interest income, leaving the bank fully hedged against this interest rate risk loss.